Hi guys, there was another question from section 1.8. I uploaded the video for problem number 19 a couple of hours ago. So I'm gonna go ahead and I'll also make a couple of more videos for a couple of more questions from this section, okay? Number 21 is the next one. So this is actually very much similar to number 19. The only difference is gonna be that our function is gonna involve a fractional exponents instead of just an integer like 6. But that's it. But all the rules of the thing is going to be very similar, okay? But anyway, so there is our function f of x, which happened to be 4th root of x squared plus 1 to the 3rd power. Guys, please excuse the barking of the dog. We have the dog in one of the rooms. Sorry about that. So as you know, there are no rules for differentiation. For radicals, anytime you have any kind of square root or 3rd root or 4th root or any kind of radical, you're going to have to rewrite it as an exponent. I'm sure you know that by now because you can't differentiate anything with radical. Okay, so we have to rewrite it. So we're going to use a basic rule from your algebra. I'm sure if you remember the rule that says anytime you have basically anything to raise to a fraction can be written as a radical. The bottom becomes your denominator. Your denominator becomes your root of the radical, and of course the m becomes your power exponent. Okay, so you can always go back and forth from radical to fractional exponents and vice versa. So that's the rule we're going to use to rewrite this expression as x squared. That's your base plus 1. So you have to the 3rd power, so that will be your m, and then also your n would be 4. So if you just rewrite this radical by this rule as exponent, it becomes 4/3. Okay, so that's it. So there's your function. So again, as I said, this is very similar to 19. I believe in 19 we had a function to a power 6. So here your power is 4/3. But you follow pretty much the same rule, okay? So again, to get the second derivative, which is the question here, we're going to have to first find the first derivatives, because of course second derivative is derivative of the first derivative. So we're going to look for f prime first. So again, a function to a power. So by the power rule, as you know from last section, the extended power rule, the power comes down times the function to the power minus 1. Now 4/3 minus 1. I guess I'll include that here. 4/3 minus 1. And then don't forget times the derivative of the function that is being raised to a power. Of course, our function is x squared plus 1. So derivative of that will be simply 2x, okay? So there, I'm just going to subtract 1. Don't forget 1 can be written as 3/3. So if you write it as 3/3, then of course this becomes, the reason you want to do that because you have the same denominator. Now you can combine them to a single fraction. So 4/3 minus 3/3, which becomes 1/3. So now you have, oh, by the way, I'm going to go ahead and multiply 2 times 4 to rewrite that. And then also, if you don't mind, I'm going to bring the x to the front. It's all multiplication, doesn't matter. And then, of course, I'm just going to write 8/3. And then x, this is this x. And then, of course, times x squared plus 1. Raised to the power 4/3, again, minus 3/3, which becomes 1/3. So there's your first derivative. So as very similar to our last problem, number 19. Now you want the second derivative. So you want f double prime. So the second derivative is, of course, derivative of the first derivative. So you differentiate again. But this time, now, by the way, if there was no x, if it was just 8/3, that would be a constant. So remember, constant multiple rule. You just leave the constant and then multiply by the derivative of this function. Except there is a variable, there is an x. So we're going to have to treat this as a product. So basically, once again, we have a product of two functions. You can think of the first function as 8/3 x and your second function as x squared plus 1 to 1/3. So therefore, again, you have a product. And hence, you have to use the product rule to differentiate, okay? So I'm going to go ahead and, I don't want to go, let me go one more step here and then I'll move it upstairs because it's kind of hard to see in the bottom. So again, this is your first function. So the product rule says the first function itself. I'm going to put the derivative inside the bracket times the derivative of the second. Now your second function itself is a function to a power. So we have to use the extended power rule, which says the power 1/3 times the function raised to the power minus 1 again, which is 1/3 minus 1. Sorry. 1/3 minus 1, and then again, don't forget times the derivative of the function again, which in this case will be 2x once again. Okay? So now, and then plus, don't forget, I was about to myself forget the second half. So remember, the product rule says the first function times derivative of second. So this is the derivative of second, all of that. And then plus the second function times derivative of the first. Now your second function is, of course, x squared plus 1 to the power of 1/3, and then times the derivative of the first. The first function, of course, is 8/3 x. So as you know, derivative of any number times x is just a number. So it will be times 8/3. Okay, so there's your second derivative. So basically what's left is just to do some arithmetic and some basic algebra, but that's pretty much your second derivative. Okay, so the calculus is pretty much over. Well, let me see if I can rewrite it a little bit cleaner, just to have it a little nicer. But again, I don't know how far the back of the book goes with the algebra, so I'm sure you can check it. These are the odd problems, so the answer is on the back, so you can check it, of course. So first of all, I'm going to multiply everything cross. So 2 times 8 becomes 16. And then 3 times 3 become 9. So that'll become 16/9. I'm just multiplying all the numbers together. And then I'm going to put the x times another x, which gives you x squared. And then, of course, times x squared plus 1 to the 1/3 minus 1. But, of course, what is 1? You can write 1 again as 3/3. And 1 minus 3 becomes -2. So that becomes -2/3. And then plus 8/3, I'm going to put the number first, 8/3, and then of course times the function x squared plus 1 to the 1/3. Okay, so this is pretty much the answer. Again, the book might write those as radicals, because remember this rule, you can always change that. And let me actually go one more step. But again, either one is okay as long as you know, you get to here, but sometimes the book does do some changing the exponents to radicals. So let me just do that, but you can decide which one they have in the back. But you need to understand, of course, both are the same. So the -2/3 becomes basically, you can actually move that downstairs. I'll write that as a positive 2/3. As you know the rule, anytime you have a negative exponent, you can realize 1/, and then the exponent become positive. And that one they can write as a cube root. Again, by this rule, anything to 1/3 is the same thing as cube root of that same expression. And you can also finally change this one. I'm going to actually let you look at this, and then I'm going to change it. If you want to change this also to radical, you can actually rewrite this as the 3, which becomes cube root. And then, of course, the 2 becomes your exponent. Okay, so you can also write it like that. So either one. But again, you can also factor 8/3 out. So you can do other stuff. But mostly, this is pretty much a couple of ways you can leave your final answer. Okay, but if you don't get the same thing as the back here, or this is not the same thing in the back, and you can't get to what they have, you can send me a message, and I'll try to work it out further for you. But this, I'm pretty sure what's left should be probably maybe algebra or something. Okay. All right. So I'm going to make one more video in a minute, but let me go ahead and pause this one, because this got kind of a little bit too long. Okay.